Today's class shall be about LIDAR data. What is LIDAR data? Well, I don't know, so I'll just Google LIDAR data and I will look at images and it will tell us, oh, look, all these points. Wow, points. Okay, so now I know LIDAR data is point clouds essentially. Essentially what happens is cities or government agencies, they fly UAVs or helicopters or anything across, cities, and they shoot lasers at the city, right? These lasers aren't killing anything. All it's doing is grabbing elevation data points. And so these lasers create what is known as these Elias point clouds. And so that's in a nutshell what LIDAR data is. It's a point cloud data set. What's good about this information is that it's probably the highest possible resolution elevation data source you can find out there. And so if your site for whatever project you're working on has LIDAR data available, it would be in your best interest to access that information, because you're going to get information that's probably as good, if not better, than your traditional survey out there. And so I'll illustrate that point in today's tutorial. The best data source for most LIDAR in the United States. If you're trying to go international, I can't help you, but for the United States at least, is the National Map Viewer that you use to download DEMs. So in here, there's this thing called elevation source data on the side. And at the very end of this list of stuff to download, there's LIDAR point cloud right here. So if you want to find LIDAR data, you want to check that box. If you click on show availability, this is where LIDAR is available in the United States. So as you can see, it's not everywhere, but it's in most areas, I guess, major urban areas of the United States. So for today's tutorial, we're going to focus on St. Louis. So with that checked, I'm going to zoom in to St. Louis, and we're going to do Forest Park. So I'm going to zoom into Forest Park. And just like you would download DEM images, you draw a box around the area that you want to get image data for, so Forest Park. Click Find Products, and this gives you all the data sets that you can download. So the one you want to download for this tutorial is USGS LIDAR Point Cloud, but you don't have to download it because I already downloaded it for you. It's in the folder here, this Elias. All this stuff here is what you would get when you download it. But just so you know, what I downloaded was this line here and this line here. And just to review, the way you do it is you just click on the shopping cart to grab that information. And also if you click on the thumbnail object, you can see what region it covers.
Does DEM imagery come from this point cloud data?
Most likely, yes, it does. And in fact, you can create your own DEMs from LIDAR point cloud, and I'll show you how to do that. That's what.
It takes into account like trees and buildings and stuff.
Yes, it takes into account trees and buildings and stuff, Yeah. So, and then with those checked, you go to View Cart and you can download this information. When you download this, you want to download the LAS data set. So I didn't download the LAZ. I only downloaded the LAS. And then when you download it, you get a couple of zip files. That's down here at the bottom of my Chrome browser, and then just unzip those zip files, and you will get files that look like this. All right. So with that stuff all set up, I'm going to bring that into GIS. So in GIS, I just have a base with the building footprints here, and since we're in Forest Park, I'll move my data frame to Forest Park. So the way you bring LAS datasets into GIS is you go to the ARC toolbox, and you go to the data management tool. And in data management, there is this folder toolbox called LAS dataset. So you go to ARC toolbox in data management, and then LAS dataset, and there's this thing called Create LAS dataset. So you double click on that. And what you want to do is in this first line here, this little folder, you click on this little folder, and you navigate to where the Elias data is saved. So I already have it right over here. You see these two files because I downloaded 2 files. So you open those in there, and then you want to create an output location. So it usually automatically just saves to your ArcGIS desktop folder, which is okay, not a big deal. And I really just leave the name as is because I don't really care about that. So as you can see, I haven't done anything. Everything's good. So just click on OK. Just give it a second, and that is it. So you've created an Elias data set. And this data set is only viewable at certain distances. So right now you don't see anything, but if you zoom into the map, you begin to see these points pop up. And these points are, as you can see, at elevation, or point elevations. So what are some things you can do with this data set? Well, the first thing you can do is you can take a section of this. So if you right click on your toolbar up here, you can open the LIS dataset toolbar like so. And so for today's lesson, I was interested in Forest Park, so I quickly went on Google and I just tried to find some interesting topographical regions of Forest Park. So for instance, the Art Museum and the bowl facing the lake here. Let's say you want to take a section of this whole region right here. So let's find it, it's right over here. Yeah. So what you can do is you can click on this little LES dataset profile view tool here. And you can essentially draw, which is like a section box, like so. And you see what happens is you draw a line for the section, and then you can draw a rectangle for basically the amount of points within that rectangle that you want to reference. And you see you can't do a lot of points because of the limitations of the software or of the program. But if you click on that, you can essentially get a sectional view of this whole area. And the areas with water actually don't get the points, but you can see from this view here, you get the roof of the art museum, and you also get the ground plane. And anywhere that the points hit trees, you get the points as well. So this is pretty cool, right? You can increase the amount of points that are sampled by going into the LES dataset thing here and clicking on Profile Tool Options. And you see this little point budget, you can just ramp it up to the maximum number here. So then you can click on the same thing again. Maybe let's just focus on the hill. And you can increase the number of points. You can see you can increase it significantly there. And you can begin to see a profile view of that area. So areas with trees, you can see it actually picks it up. So if you need to get information on tree heights, I would say this data set is probably your best source for that information, because you can get the tree heights from that. What you can also do is you can also view it like a mesh. So if you go to this elevation button right here, if you click on that, it renders this whole thing as a mesh. Let me turn off the building footprints for a second. So this is kind of the data that you can get from this information. Basically pure elevation data. As you can see, it's very similar to what you would get from a DEM. You get classes of elevations that allow you to know the heights of certain features. And if you zoom in, you can see the quality of the mesh increases because more points can be sampled within the view. So this is very powerful. What else can you do with this? Okay, but you're saying to yourself, all right, Frank, this is great. I just want to take this and I just want to bring it to Rhino. I just want my models in Rhino, because whatever. This is fun in GIS, but at the end of the day, I got to design with this stuff. I got to find a way to take this information and use it in a meaningful way, right? So let's do that. So I'm gonna move this up here for a second. This toolbar. It's right over here. Actually, let me bring it down. Let's leave it over. So how do you take this information, and I'm going to turn back to a point view, and turn it into a surface? There are two types of surfaces. There's what's known as a DEM, which is what you've been using around, and there's also what's known as a DSM. Digital elevation model is what you've been using. It's basically pure elevation data of the ground plane with no vertical features considered, buildings, trees, whatever. DSM is a digital surface model, and this takes into account trees, this takes into account buildings, this takes into account all the vertical features on a site. So with LIDAR data, you can create DSMs as well as DEMs, but I'm gonna show you how to create a DSM. So it's pretty easy. You just zoom into the area that you want to create data for. Let's say this area in Forest Park. You go to Toolbox, or Toolbox. You go to the Conversion Tools. Conversion Tools. And then there is a option called To Raster. And in To Raster, there's LIS data set to raster. So double click on that. And you want to drag in the LIS dataset you just created into the first line here. And then the output raster, you want to save it in a location. So I'll just click on the folder on the side and we'll call this one Forest Park. And you always want to end it with .tiff because that will make it a raster that you can use as a data set. So click on Save. And then the next important thing is this cell size option here. So at this point, you might do some trial and error to see what resolution you can get from this number here. Let's try 2, for instance. Obviously, the smaller the number, the higher the resolution of the raster. And then I would recommend going to the Environments tab and clicking Processing Extent and setting that to be same as display. That way, you're only creating a raster for the region that the data frame is viewing. Then click OK. Just let it do its thing. And there you go. You've created a DSM, digital surface model, of this forest park. This operates in the same exact way that a DEM would work. So you can cut contours from this. You can do anything with this. If to this point you were following the tutorial, you can do this. But if you didn't follow the tutorial to this point, in the folder here, I created this DSM FP3, which, if I add it, is basically the entire forest park region turned into a DSM, like so. And you can see, like for urban areas like Central West End, you get the building heights for this whole region, which is pretty nice. So what can you do with this? Well, you can cut contours. So let's cut contours. I'm going to use the one I made for today's tutorial. So let's say you want to cut contours of the whole thing. You go to Arc Toolbox, go to, you know this already, you can go to Raster Surface in the 3D Analyst tools, go to Contour, and then you can drag in the TIFF you just made. I always recommend leaving this as is, because for some reason if I change it, it sometimes doesn't work. I don't know why. And then contour interval. This raster data set currently is in meters. I know this just because I kind of know the elevations of St. Louis. It's not within the range of these numbers, so these numbers are in meters. So let's say you want to cut 5-foot contours, so you always want to add a factor of 3.28084 to turn the meters into feet. And that's okay. I will cut contours for this whole raster because it's not that big of a site. So click OK. Let's do its thing. Okay, so what the result that you get from that process is contours. So you can see, you can zoom into this area. You can see you get contours of the building, which is kind of funny. But you also get contours of the whole forested region as well. So you could, in theory, take this whole data set, you can export it to Rhino, and you get basically a kind of a contour mesh of the entire region of Forest Park. You can kind of see where the trees are located. So this is actually a very good data set to use to essentially build sites from scratch. Let's add a symbology ramp to this. So I go to Quantities, Value, Contour. Whenever you see that stuff, that's this window come up, you just want to go to Classify, go to Sampling, and just increase this number like to a really big number, and then it'll be fine. So now you can see. Let's make a fun color ramp, so you kind of see this elevation data. for the region. And then obviously you can export this to Rhino as CAD lines. I'm not going to show you how to do that because I already know how to do that. Okay, this is good, right? Now let's say you don't want the trees. You don't want the buildings, right? You want to create a DEM yourself. The way to do that is in the Elias dataset toolbar, you can set the filter to be ground. What this does is it only displays the ground points. So now it filters out everything that's a vertical feature, such as a building, such as a tree, and it only shows the ground level points. So these data sets have already been classified that way as to basically isolate those points. So what is the purpose of this? The purpose of this is to create really, really high-res DEMs. So let's say you want just the best possible contour data set. You use this. You can create DEMs of a higher resolution than anything you can download off the internet. So let's create a DEM of this region of St. Louis again. So I go to art. With this filter, oops, what did I just do? Okay, so with this filter ground selected, go to the toolbox, go to the LAS dataset to raster, the same tool that I showed you earlier. Do the exact same thing. So we'll drag in the dataset here, set the raster to be, say, art museum.tiff. And you can create, in the cell size here, a really high-res TIFF. So I did 2 previously. You can do something like, 0.5. And then set the environments to be, the processing extent to be the same as display. Then click OK. Okay, then when it's done, this is the result. As you can see, you zoom in, you see it has an extreme level of detail. Like the pixel sizes are really, really tiny. And this is what I was saying, like if you want contour information for sites without having to get a surveyor, this is a really, really good way to get that information. So let's cut contours of this new DEM. You see it's different from the DSM, which includes the vertical features. This is clean and only contains the ground. So you can go to contour, drag this in here like that. Cut the contour interval would be 1 because we want 1 foot contours, and then in the Z factor 3.28084. And then click OK. I don't have to set processing extent because it already set the raster is already of that size, so it's OK. And this is great. As you can see, these contours are really, really nice. You even get the grading of the parking lot. You can see right here. And you get the grading of the road as well. This is a really, really refined data set, and you can use this to design sites with a great level of precision and detail. So yeah. Okay, so contours is good. Let's say you want to cut a quick section from this, right? So there is this tool in ArcMap that I discovered fairly recently that was kind of mind-blowing. It's within the 3D Analyst, let me close this, the 3D Analyst toolbar, and it's this thing called Functional Surface. And in here, there's a few tools that are actually extremely useful in conjunction with LIDAR datasets. There's this first one called Add Surface Information. There's also this one called Interpolate Shape. So interpolate shape basically means you can project a line onto a surface like this here and basically get a section cut. So let's say you need a long section. You can do that using this data set here. So let's, in the drawing toolbar up here, you can find, if you don't have the drawing toolbar open, you can click on the draw option here. You can draw a line. Let's say you want to cut a section straight through this portion of the site. So I'm going to draw a line. To turn this line into a data set, you just got to select the line, go to drawing, and click on convert graphics to features, and then just pick a location. I'll call this one, I'll save it in my junk folder. You always need a junk folder when you're working in GIS because you can create a lot of junk. I'll call this section, and then check this box, automatically delete. OK. If you open the attribute table for this, you see it's a very simple data set, nothing basically. So with that chosen, you go to functional surface, interpolate shape. And the input surface, let's say you want to do, let's do the DSM because that's more fun. So let's open that guy up, drag this into the first surface here. And then the input feature is the section line. And you can do this data set could have multiple lines in it. It doesn't have to just be one line. You can do like 5 lines at the same time. I'm not going to pick a location for now because I don't care. But all this selected, just click OK. I'm also open Rhino so you can see it in 3D. So this is the result. You can't see it in 3D because ArcGIS is not a 3D tool. And then I'm going to take this, go to Data, Export to CAD. I'm saving my desktop. I'll call this section. And whenever export to CAD, go to Environments, Output Coordinates, same as display. Processing extent, same as display, I guess. That's okay, yep. And cartography, same as display. And then Rhino, open that new thing you made. So let's go to my desktop. So now essentially you've cut a section through that portion of the site. And you even get the trees, the kind of tree heights as well. You see it looks kind of weird. That's because it's kind of cutting a section through. The line doesn't know what's a tree and what's not a tree. So it's cutting, like when it's doing that, it's basically cutting through like a hole in the trees, like where the sun goes through. But you can use this as a way to kind of get a general sense of the height of this region. And let's say you can also do this. You can also, let's go to this section guy here, go to Edit Features, start editing. And let's just add a few more lines. So I'm just going to take this, copy and paste it a few times. And then I'm going to save the edit. So save edits, stop editing, and do the exact same thing, interpolate shape, but this new feature class. This right here. This. Then click OK. Take that, export that to CAD. Do the exact same thing, same display, same display, same display, okay, okay. Then Rhino, let's open that new thing. And you can begin to cut like serial sections through sites using. So building heights, hills, everything. So whenever, if for instance you have a professor, let's say Gia, who I had as a student when I was a student, and she loves cutting sections through sites for some reason. And when I was a student, I didn't have this tool, but she's like, yeah, cut a section through the entire site. Well, now I know how to do it, but now I'm no longer a student, so this is useless.
Thank you for telling us, right?
Yeah.
We'll show Gia.
Okay, so using LIDAR data, you can actually build massings of buildings with the correct building height really, really efficiently. So what you need is you need a DSM, which we made, and you need a building footprint data set, such as the one you see right here. Now, before you do anything else, you want to make sure that your building footprint data set is appropriately trimmed. So for instance, you see this, this building right here in Central West End. It's one giant shapefile. But this is not, one roof. This is multiple roofs together. And so before you do anything with this, you always want to make sure that your building footprint layer is appropriately actually of the correct geometry. So if you run into a condition like this, you actually want to edit the building footprint. So with this building footprint selected, I'll go to Edit Features, start editing, and then the editor, usually the editor toolbar will pop up, and you want to select. In this case, I'll make the fill nothing. I'll make the edge like a blue or something, so you can see it better. You want to take this shapefile. You want to start to split it along, the areas where you can clearly see that you have different heights. So this is the split tool right here, cut polygons, right? And with a feature selected, if you have nothing selected, this doesn't work because there is no selection. So you have to select an actual building footprint, say this one here. You have to use the cut polygon tool, and you want to just cut areas where you see like a change in height. So you can see that using the gradient here, there's a change in height there. There may be a change in height there. Whoops. Sometimes you might need to cut through several things at the same time.
Are you just dragging it like outside of the?
Yes.
Like automatically?
Yeah. So what I do is I click on, say, like a portion of this, and then I double click to end it. Double click to end. So sometimes when we're building city models at the office, I have to do a little bit of this kind of boring work to get to that point. But it's way better in my opinion, than to go on Google Earth or however you would do it in the past, and like measure building heights and then trace buildings and getting the heights that way. So I'm just gonna do this for a few times for this little portion right here. Okay, that looks okay. Maybe let's cut this one here a little bit. You can see just a lot of detail on this area here. Okay, good enough for me. So then what you do is once you're done with this whole thing, you click on Save Edits and let it save. Then stop editing. Okay. So for this tutorial, I'm only going to do Central West End, this region here, the Central West End Cortex region. So I don't want this entire building footprint, so I'm just going to quickly export just this area here. So I'll just go to Data, Export, Data, and Features and View Extent just to get that region. I'll set the coordinate system to be the same as the data frame, and I'll just save it as, say my junk folder, call this CWE Buildings. Okay, then what you do is you need to convert these buildings into points. So we're going to go to Data Management, Features, Feature to Point. Bring in this shapefile, and it's just going to save it in your default geodatabase, and that's fine because actually whatever the result from this, we're going to delete in the future because it's not that important. Then check this inside box here, then click OK. The inside just basically means the point that's generated will be within the building center. Okay, so for some reason the function didn't work previously, but now it has. So when you've converted your shapefiles to points, you want to use a tool called, in the 3 Analyst functional service folder, there's this tool called Add Surface Information. So what you do when you have your points is you go to this function called Add Surface Information. And then what you do is you, in the first line here, bring in your point data set. And then in the surface, you either bring in your DSM or your DEM. In this case, I'll do the DSM, which is this guy here. And then you want to check this output property Z. And that basically means it's going to get the Z value at each of those point locations. So that's all set. Just click OK. You're good. And then if you open the attribute table here for the point data set, you see you now have a Z value right here. So this number you can use to get the elevation data for each of those buildings. So we're going to use the join function, and so we're actually going to use the join function in the ARC toolbox because that allows the number to be permanently joined to the building shapefile. And so that is in data management, joins, and then join field. And so the input table is going to be, let me see. The input table will be the original building footprint, so which is CWE buildings, and the input join field will be the FID. The FID is basically this ID number right here. And then the join table will be the point data set, and the output join field is going to be the original FID. This is what's carried over from the previous conversion. So that is set as original FID. And then which field will be joined? You want to check the Z box right here. So that means the Z value from the new point data set will be joined to the original shapefile. So just click OK. Okay, so that's finished. So then if you turn off this point data set and you open the attribute table for the original building data set, you see you now have a Z number right here. So we're going to bring that into Rhino. So I'm just going to, what I always do to make sure the elevation data is converted over correctly is I type in elevation, add field, and I'll set as a double, right? And then I'm going to go to field calculator, and where elevation is going to be equal to Z, but I'm going to multiply that by 3.28084 because these numbers here are in meters. So we're going to convert that to feet, like so. And then with that set, and actually before I do anything else, I want to make sure my coordinate system is set to something that's in feet, which it's not. So I'm just going to go to my favorites and set that to State Plane, Missouri feet, right? And then we're going to take that building footprint data set, go to data, export to CAD, save it on my desktop. Buildings, environments, opera coordinates, same as display, processing extent, same as display, cartography, same as display. Okay, okay. Oops. Then open that up. And okay, so that worked. So now you can see that all the buildings now have the height associated with it. Black. If you go to profile view, you can see that all the buildings have their height. So what you can imagine doing is you can export one of these files, and you can export a contour base file, and then you can get a lot of information for your urban fabric. In fact, let's just do that. Might as well. Let's zoom in.
They're already updated.
Yep. So let's say you want to take this and cut contours from this. So we'll just do quickly surface contour. We'll do just quick like 5-foot contour. Use a conversion factor. Set it to be same as display. Okay. Okay. And I'm going to show you one last thing today, and that's what I was mentioning, how to represent contours in a good way.
Is it hard to align the contour in the building?
What are you saying? Is it hard to?
Right?
Everything, it will just come in the right location because everything's geo-referenced. Like if you
So then you just extrude the buildings?
right, you would just extrude the building down to the contour layer. You could like write a grasshopper script that just does it automatically if you wanted to. I'm not going to show you how to do that today because that's not the point of this class. It's not to teach you guys grasshopper, it's to teach you guys GIS. But there are probably ways you can do this using grasshopper. So just for this tutorial, I'm going to use this art museum area. Actually, I'm going to do this. I'm going to create a real quickly. I'm going to create a and then we'll be done. So I'll create DEM of this region, so Elias. Oops, not this one.